Hi everyone, welcome back to SAT 021. Today let's talk about exponential expressions and functions and radicals. First, let's see some basic rules for exponents and radicals. If we take the mth root of x to the power of n, we can rewrite the expression as an exponential form, x to the power of n over m. And if we take the reciprocal, like 1 over the mth root of x to the power of n, the expression becomes to x to the power of negative n over m. So we may apply these two rules to see one question. Question number 1. Which of the following expressions is equivalent to 2 over the cubic root of x to the power of 4 and then to the power of n? So we may apply the second rule. 1 over the mth root of x to the power of n equals x to the power of negative n over m. So the expression becomes to 2 times x to the power of negative 4 over 3 and then to the power of n. And then we may distribute the n's power. So the expression becomes to 2 to the power of n times x to the power of negative 4 over 3n. So the correct answer for this question is B. So for question 2, we will show you how to solve a radical equation. What is the sum of the two roots of the equation below? X minus square root 7x minus 31 equals 3. So we have to find the roots first. The first step, leave only one radical at one side of the equation. So for this one, we just leave the negative square root 7x minus 31 to the left and move the x to the right. In the second step, square both sides of the equation. And the third step, simplify both sides of the equation and get rid of the square root. So for the left-hand side, the square root and the squared cancel. So it becomes to 7x minus 31. And for the right-hand side, we just open the brackets. So that becomes to 3 squared minus 6x plus x squared. And the fourth step, which is simplify and solve the equation. So we may calculate the 3 squared and then move everything to the right. And then combine the like terms. And then apply the method of factoring. So the equation becomes to 0 equals x minus 5 times x minus 8. So the two roots of the equations are x equals 5 or x equals 8. And for radical equations, there is one more step we have to follow, is we have to check the extraneous roots. So we have to substitute the two roots back to the original equation. First, we substitute x equals 5 back to the original equation. And the left-hand side equals 5 minus square root 7 times 5 minus 31. And that is 5 minus square root 35 minus 31. And 5 minus square root 4, which is 5 minus 2. And that equals 3. And that equals the right-hand side. So 5 is the correct answer. And we may also substitute x equals 8 back to the original equation. So the left-hand side equals 8 minus square root 7 times 8 minus 31. And that is 8 minus square root 56 minus 31. And that is 8 minus square root 25, which is 8 minus 5. And that equals 3. And it also equals the right-hand side. So x equals 8 is also a proper solution for the equation. We got the two roots. And the two roots are x equals 5 and x equals 8. And the question asks for the sum of the two roots, so we just add them together. 5 plus 8 equals 13. So A is our correct answer. So let's review the steps for solving radical equations. The first step, leave only one radical at one side of the equation. And the second step, square both sides of the equation. The third step, simplify both sides of the equation and get rid of the square root. And the fourth step, solve the equation. And the fifth step, is our important step. So is that we have to check extraneous roots for radical equations. So let's move on to exponential growth and decay. When a quantity is increased or decreased by a constant factor, we may use the exponential functions to model the growth or decay. So the basic model is a equals a0 times b to the power of t. If b is greater than 1, the function represents exponential growth. We may see a graph, and the quantity is increasing. If b is between 0 and 1, the function represents exponential decay. We may also see the graph, and we can see the quantity is decreasing. A0 represents the initial amount for the quantity, and t represents the time, and that usually in years. So we may see one question. An investment of 85,000 increases at a rate of 11.5% per year. Find the value of the investment after 20 years. So we have to find the b first, and the b equals 1 plus 11.5%, and that is 1.115. And our initial amount is 85,000. So we may substitute the numbers into the model. A equals 85,000 times 1.115 to the power of t, which is 20. So 1.115 to the power of 20. And we may calculate the number. So that's our final amount of the investment. So that's the end for this topic. See you then.